While browsing onwards for inspiration for my next project, I came across this beautifully designed website for a creative studio. The site focuses on storytelling through clean layouts and subtle interactions, making the browsing experience feel really elegant. One section, in particular, caught my attention. As you scroll through different moments in the timeline, each event is connected by a smooth, flowing SVG path. Instead of using straight lines, the connections gently curve from one section to the next, making the entire timeline feel much more natural and visually engaging. I thought this was a really interesting effect, so I decided to recreate something similar using React and GSAP. In my version, we'll dynamically calculate the position of each section, generate smooth SVG paths between them, and make sure everything updates automatically whenever the layout changes. If you enjoy these kinds of React and GSAP animation tutorials, don't forget to subscribe to the channel and leave a like on the video. Now, let's jump into the code. Inside app.jsx, there's nothing special going on. I just have a simple hero spacer at the top, the main component in the middle, and a footer spacer at the bottom. Inside the component, I first create a few refs and state variables. The container ref gives us access to the entire timeline section, while the other refs keep track of each text block and the SVG paths we'll be working with. I also create two pieces of state, one to store the SVG's dimensions and another to store all of the generated path segments. Next, I create the main section and attach the container ref to it. This section acts as the parent for both the timeline content and the SVG overlay that we'll generate later. I also give it a simple background color and some spacing to match the overall design. Right after that, I add an SVG that covers the entire section. This SVG will hold all of the connecting lines between the timeline entries. Instead of using a fixed size, I bind its viewbox to the value stored in state, so it always matches the dimensions of the container and stays perfectly aligned with the content. Inside the SVG, I first define a mask. For every path segment we generated earlier, I create a corresponding mask path and store its reference so we can access and animate it later if needed. This setup is important because it gives us direct control over each individual segment of the journey line. We'll use these references later for the animation, while the mask itself lets us control exactly which parts of the SVG path are visible, effectively revealing the line progressively instead of showing it all at once. After that, I render the actual timeline paths by mapping over the same segments array. Here, I apply a dash stroke and attach the mask we just created. This gives us the final curved connector that follows the timeline, while also preparing it for the animation we'll add later. After the SVG, I create another container that will hold all of the timeline content. I position it above the SVG using a higher z-index, so the text stays fully visible while the connecting path sits neatly behind it. This also keeps the content and the SVG nicely separated, making the layout much easier to manage. Now I map over the stops array, which I've imported from the assets file. It simply contains all of the timeline data, like the text, images, and a few other properties for each section. As I loop through the array, I create a two-column layout for every timeline entry. Depending on the data, I also swap the order of the columns so the layout alternates from one section to the next, making the timeline feel much more dynamic and visually balanced. For the first column, I simply display the image for the current timeline entry. It's wrapped inside a container with a fixed aspect ratio, rounded corners, and a few styling classes to match the overall look of the design. For the second column, I just add the text content for each timeline entry and attach the corresponding ref. We'll use these refs later to calculate the SVG path positions automatically. Before starting with the GSAP part, make sure you've imported the required packages and registered the plugins. The first thing I do is create a measure function. This function is responsible for calculating the position of every timeline entry. I start by getting the container element and its bounding rectangle. Then, I loop through all of the text refs and calculate the center position, along with the top and bottom coordinates of each one. We'll use these values to generate the curved SVG paths that connect one timeline entry to the next. Next, I generate the actual SVG paths. I loop through the anchor points two at a time, treating one as the starting point and the next as the destination. Then I calculate a midpoint between them and use it to create a smooth Bézier curve instead of a straight line. Each generated path is pushed into an array, and once all the segments are ready, I store them in state. I also save the current width and height of the container so the SVG always matches the size of the timeline. Finally, I wrap everything inside use GSAP. I call the measure function once when the component mounts, and then create a ResizeObserver that recalculates the paths whenever the container size changes. This ensures the SVG connectors always stay perfectly aligned, even if the layout changes because of a window resize or responsive adjustments. I also disconnect the observer during cleanup to avoid any unnecessary listeners. Now it's time to animate the SVG path. First, I grab all of the path references from the mask and calculate the length of each one. Then, using stroke-array and stroke-offset, I hide every path completely. This is a common SVG animation technique that makes it look like the line is being drawn progressively. Next, I create a timeline with a scroll trigger. As the user scrolls through the timeline, each SVG segment is revealed one after another by animating its stroke-offset from the full length down to 0. Finally, I call scrollTrigger.refresh to make sure all of the measurements are up to date after everything has been initialized. Since the SVG paths are generated dynamically, I pass the segments array to use GSAP so the animation updates when the paths change. I also enable Revert on Update to clean up the previous animation and prevent duplicates. And here's the final result. Using React and GSAP, we built a dynamic timeline where each section is connected by smooth SVG curves that are generated automatically based on the layout. As you scroll through the page, the journey line is progressively revealed, creating a clean and engaging storytelling effect that's commonly seen in modern editorial websites and portfolios. If you enjoyed this tutorial or learned something new, don't forget to leave a like and subscribe to the channel. Thanks for watching, and I'll see you in the next one.